Hello students, in our previous lecture in metals and non-metals, we have discussed about some of the important compounds of non-metal. So we have gone through some of the important compounds, like we have discussed about the ozone, which is an important layer in the atmosphere. Secondly, we have discussed about the hydrogen peroxide, which is used as a reagent. Thirdly, we have discussed about ammonia and nitric acid. Now we are left with some more compounds of the non-metals that we are discussing today. So in this category, we have our next compound, that is sulfuric acid H2SO4. So our next compound is sulfuric acid. So sulfuric acid, as you all know, is a acid having a chemical formula H2SO4. Now this H2SO4 is having a general structure which can be written as general structure of H2SO4 is this will be the general structure of H2SO4, and now sulfuric acid is basically used for the preparation of other type of acids like nitric acid and many more acids. Secondly, it is used in batteries, it is used for extraction of metals, it is used in electroplating, and it is also used in the petroleum refineries. So having 100 of use of the sulfuric acid in industry, it is regarded as a king of acids. So which is counted in the king of acids? Only the one main acid, that is sulfuric acid, is known as the king of acids. So firstly, sulfuric acid is used in preparation of many acids. Secondly, in electroplating. Thirdly, in batteries. Next, in petroleum refining. Next, as a laboratory reagent. Next, in extraction of metals. So you can see here, there are numerous uses of sulfuric acid in our day-to-day life. So having so much uses, the sulfuric acid is known as the king of acids. So having numerous uses, in industry, this sulfuric acid is regarded as a king of acids. So which is called the king of acids? Sulfuric acid is known as the king of acids. So it is all about the sulfuric acid, which is basically a compound that is formed by using non-metals. Now we are forwarding to our next organic compound, or the next compound that is formed from non-metals, and our next compound is sodium chloride. So that is ammonium chloride. So sixth compound is, we have ammonium chloride. Ammonium chloride is having a general formula NH4Cl. So its general formula is NH4Cl. Now, ammonium chloride is also termed as a nosadar. It is extensively used in textile industry. It is used as a laboratory reagent. It is used in dyeing industry. It is also used for the formation of. So, our next category is ammonium chloride having a general formula NH4Cl. NH4Cl is usually termed as a nosadar. So, we can call it as nosadar. Now, this nosadar is actually used as a soldering material used for soldering purposes. It means in the purpose of soldering, the material which is formed is basically formed by using the ammonium chloride. Secondly, it is used as a laboratory reagent. Thirdly, it is used in dyeing purposes. Fourth, it is used in also electrical appliances also, and it is also used for the textile industry. So, its basic uses are used as a soldering type material. Secondly, it is used as a laboratory reagent. Thirdly, it is used in dyeing. Used in electrical appliances. So, these are the general uses of ammonium chloride in our day-to-day life. So, what is the basis of teaching this topic in your chapter number 3rd? Because the 1 mark question that has been put up in the exam, because the paper pattern now has been changed. So, in MCQs, that is optional type questions, and the very short questions, these questions can be arises from the uses of some of the compounds in our daily life. Now, after sulfuric acid and ammonium chloride, we are going to discuss about the HCl, that is hydrogen chloride, or we can say that it is hydrochloric acid. So, before specify that, you can copy it from here, so we can proceed to our next topic. Now, our 7th category of the compound is hydrochloric acid. The hydrochloric acid is generally having a formula HCl. Now, this HCl is basically used to prepare the chlorine, which is used as a bleaching agent for the water. 1 part of HCl and 3 part of HNO3, 1 part of HNO3 and 3 part of HCl is basically used to make aqua resia. Aqua resia is a solution in which generally the metal are going to dissolve. It is used as a laboratory reagent. Nextly, it is used in gums and dyes, and it is also used in iron and steel industries. Sometimes it is also used in textile industries for dyeing purposes. So, these are the general uses of hydrochloric acid, that is HCl, in our daily life. And sometimes it is also known as the salt of chloride because its name is HCl. So, basic points regarding hydrochloric acid are: it is known as salt of chloride. Nextly, it is used in preparation of chlorine. it has its use in preparation of chlorine, and this chlorine is used as a bleaching agent. It is also used as a laboratory reagent. It is used in the preparation of gums and dyes. Nextly, it is also used in iron and steel industry. So these are the basic uses of hydrochloric acid in our day-to-day life, that it has a many application regarding industrial field as well as our daily life. Now we are proceeding to our next topic, that is SiO2, which is basically known as silicon oxide, and this silicon dioxide have a many purposes in our life. So our next topic is, that is our 8th compound, that is silica. This silica is having a general formula SiO2. It means silicon dioxide. Now this silicon dioxide is a major constituent of the sand, and we can say that in the composition of the sand, silicon dioxide has a major composition. Now this SiO2 can be used as a clay, and in sometimes it is also used for manufacturing of the cement. Kieselguhr is an important compound of silica which is used for making dynamite. Jasper is a semi-precious stone which is also used as a silicon dioxide, and silicon, which is prepared from SiO2, is used for manufacturing of semiconductor transistors and alloys. So we can look for the basic uses of silica in our daily life. So it is actually the composition of sand and clay. It means it constitutes of requisite proportion of sand and clay. Next is Jasper. Jasper is actually a semi-precious metal. It is a semi-precious metal contain silica. Next use is silicon is prepared from silica, which is used for electronic purposes. Now silicon, and that silicon is actually prepared from silica. Silicon is prepared from silica, which is used in semiconductor, transistor, and alloys. So this is the next application regarding silica. Now Kieselguhr is an important constituent of silica which is used for manufacturing of dynamite. So our next use is Kieselguhr. As you have to remember it by the name, Kieselguhr is somewhat an allotrope of silica which is used for the manufacturing of dynamite. Is an allotrope of silica. And this Kieselguhr is actually used for manufacturing of dynamite. It means this Kieselguhr has an application involving dynamite. So it is used for the preparation of dynamite that is used in industries. So we have seen here some of the important uses of hydrochloric acid and silicon dioxide in our day-to-day life. Now in category of non-metals, we have our last compound, that is cement, we are going to discuss, which is an important constituent in our industrial purposes as well as for the construction purposes. Then we will discuss about some of the compounds that are formed from metals and have an application in our day-to-day life. So our next topic will be cement. So before this, you can copy it from here. So our next topic of discussion will be cement, which is an important construction material. So the last compound we have in the category of non-metals is cement. So this term is very common among all. You have already heard about this term so many times, but what is the chemical composition and the chemistry of the cement we will going to discuss now. So cement is actually a basic construction material and a very important construction material that is used in the industries and factories. But the production of the cement in our countries will start in the last decade, that in the year 1914. In Rajasthan, the construction or the production of the cement has been done before 60 years ago. So it has been 60 years that the production of the cement has been tremendously increasing in Rajasthan, in some part of Chittorgarh, Sirohi, Byawar, etc. So these are the some of the cities where the production of cement is done on the very advanced level. Now the basic cement consists of a calcium oxide, that is lime, and silicon dioxide, and many type of oxides of iron, aluminium, etc. But a Portland cement have a general composition which is standardized for the manufacturing of cement. So we are discussing it now. So I am writing here the percentage composition and the chemistry of the cement and the basic steps that are used for its manufacturing. But before that, we know that it is an important construction material. Apart from this, its production has been increased in last century. In last century, its production has been started in year 1914. Apart from it, in Rajasthan, it has been 60 years that production of cement has been started. So what is our next point? In Rajasthan, it has been started 60 years ago, and its production has been done in the districts of Sirohi, Byawar, Chittorgarh and Nimbahera. So these are some of the districts where the production of cement is done in Rajasthan. Now the general cement basically consists of clay, that is lime, that is called calcium oxide and sand in the requisite proportion, and the oxides of iron, alumina and some more compound. But we have a general composition for the Portland cement. So the general composition of the Portland cement is we have general composition of Portland cement. So in the general composition of the Portland cement, what is the composition or what is the constituent of the basic things I am writing here? Firstly, it consists of clay, that is calcium oxide. The calcium oxide is present in the highest quantity, that is 50 to 60%. The second compound which is present in extreme quality is SiO2, which is actually a clay. This is lime and SiO2 is clay. Now the composition of the SiO2 is 20 to 25%. The next compound that is present in the Portland cement in 5 to 10% composition is aluminium oxide, which is a very stable compound. So the third compound is Al2O3. This is present in cement in the composition of 5 to 10%. Next compound is Fe3O4 and many more compounds are present. It consists of oxides of iron, oxides of aluminium. Sometimes it is composed of magnesium oxide also. So these compounds are present in a bit quantity. So next compound we have, that is our fourth compound, Fe3O4. It is present in the composition of 3 to 4%. Next composition of the Portland cement consists of fifth compound, that is magnesium oxide in the composition of 1 to 2%. It also consists of some amount of sulfur dioxide, and the composition of sulfur dioxide is again 1 to 2%. So this is the general composition we have discussed, and this composition is of the Portland cement. Now if clay that is used for the manufacturing of the cement, if the quantity of the iron oxide is less, we can say that this is a constituent of white cement. This is the composition of Portland cement, and if iron oxide is absent, we can call it as a white cement. So what is white cement? If we are considering white cement, so if in clay iron oxide is absent, it is termed as white cement. So there is a difference of only iron oxide in the composition of Portland cement and white cement. So we have seen here, if iron oxide is absent, we can call it as a white cement. So it is the basic about the cement we have discussed. Now we will look for the construction of the cement, that how the manufacturing of the cement is done in industries. But before, you can copy it from here, so we can proceed to our next topic. So the next topic is process of manufacturing cement. Now, what happens in the process of manufacturing of the cement? The limestone, that is CaO, and the sand are taken in the requisite proportion, and these components are grinded finally. And after the process of grinding, they are put in a rotatory kiln where the temperature is sufficiently high to fuse that material. After that material is fused, we can add some amount of gypsum. Now the gypsum is added to the requisite proportion, that is obtained from the fused material, so that the setting properties of the cement can be done and the property and the quality of the cement can be improved. So what happened earlier? We can see that in our step number 1, what we are going to do, clay, that is SiO2, and lime. Firstly, we have taken clay and lime, and these clay and lime are grinded finely in powdered form. So, after grinding these particles in the powdered form, what we have done, we have put that powder in a rotary kiln. This rotary kiln is set to a temperature of 1770 to 1870 Kelvin, which is sufficiently very high temperature. Now the second step will be, in our second step, these materials are substituted in a rotary kiln. This rotary kiln is set to a temperature of 1770 Kelvin to 1870 Kelvin. Now, when this constituent is put in a kiln, we will get some substance which is in the fused form, that is in the melted form. So, what next happens? We will get fused form of compound. After this fused form of the mixture is obtained, what happens next? We will add 1 to 2% of gypsum to this solution. Why we are adding gypsum to that solution? To setting the properties of the cement. Now, in our next step, what we will do? We are adding gypsum. Gypsum is added in the quantity 2 to 3%. Now, this gypsum is actually the hydrated salt of calcium sulfate, that is CaSO4.H2O. Now, this gypsum is basically added to improve the quality of the cement that we are obtaining. So, for the improvement of the quality and for the setting purposes, gypsum is usually added. Now, in the next step, what we are going to do? We are adding water in a mixture. So now, if we are adding water to a substituent that we are getting, we will get a gel-like substance, and after drying, this gel-like substance is converted into the hard mass. So, when water is added, it will form a gel-like substance. And after this gel-like substance is obtained, after drying, it will set into a hard mass. So, it will form a hard mass after this. So, this is actually the composition of the cement or the manufacturing of the cement we have dealt. Now, after that hard mass is obtained, some amount of fly ash is also added to improve the quality of the cement. fly ash has been added because it has the properties similar to SiO2, that is clay we are using. So after this, what will happen? We will add some fly ash. This fly ash is basically added to improve the quality of the cement. It has a properties resemblance to SiO2. In spite of using fly ash, sometimes rice bran is also used as a component. It has the similar properties to that of the fly ash. So in spite of being using fly ash, sometimes rice bran can also be added. This is optional. We can add a rice bran or fly ash. So we can add both the components by choosing any of the component from here. So after this, we will get the cement which is obtained in the form of the hard mass. Now you can see that the amount of gypsum we have added in cement decides the quality and the setting time of the cement. So basically the adding of these components will determine the quality of the cement. So finally the quality of the cement has been judged by the setting time of the component and the amount of gypsum that have been added in the solution. So you know that cement has been many applications. Its major application is also for the construction purposes only. Now we have dealt about the non-metallic compounds in this chapter. Now we are left with the metallic compounds. So our next topic will be the compounds of the metal.